1 2 1 2 1 2 1 2 1 2. Woo!
Hello guys, and welcome back to this one. And today we are going to be looking at a very interesting one, the graphical illustration, where it begins to come together, right? So we are going to be looking at seeing how we take files from a sorted array, right? Files within a file, as we already as already established here, right? And then we are going to go ahead to say, well, I'm going to pass that sorted file into a completely completely new not file, basically file in the context of the question, but obviously we're talking about an array here. So yeah, so we are going to show graphically how we go through that system in a streaming sense to get values from these guys, from this sorted list or group of sorted lists to this one list. So yeah, let's get into it. So for the sake of this teaching, we're just going to be using some of the variables held, and we're going to see how it morphs and how it goes from a group of sorted files to just one sorted file. So this is going to be our illustration. So first off, we look at the code, and we see from the code that we instantiate uh, the values, and we say they call we create the indices holder, which is a list of zeros, and then we call we start the while true. So we say smallest value and smallest file. So smallest file that was already defined is just the file holding the smallest value at that instance. So yeah, and for every smallest value we find, we are going to, or for every value we check, we are going to check through the entire file to see if there's any one that is going to be lesser than it. So that's the idea of this block. So let's start from the top, and then we're going to be moving fast. So from the onset, we said we created indexes, so we should have, okay, so these are our indexes over here. So we have them, we have 0 times by the number of number of files we have, which is the number of arrays we have. So that's why we have 3 zeros over here. We could see that here, 0 times the length of the files. So we see smallest file is equals to none, smallest file equals to 0. So we have value 0, none, basically. Yeah, and smallest file 0. So we have that here. So we see if indexes, so now say for file index in range length of files, right? So what does that, well, this file indexes is basically the length of this file, which is 3, which is what we've already established. So we're going to have 0 1 2. So we can see that here, 0 1 2. That's going to be our file index. So we say if it indexes at that file index is greater than the length of the indexes, obviously that does not make any, that will not work for this instance, because indexes at the file at the index of 0 right now is just 0, right? So and the length of the file at that index, all our files at every index has a length of what, 3. So you can just be rest assured that whenever we come here, we should be checking for 3, right? So we say current equals to files, file index, and then so we are going to check, we are going to point current to the file at file index, which is file at index of 0, which is going to obviously going to be the first file, and index at file index. So basically what we're trying to say is that we are going to check the first file, and we're going to check also the index at that of the file as well. So basically 0 is our index here, so we're going to check basically the 0 file, and then within that 0 file there also the 0 index. So it's kind of a bit of a one, but obviously we know we are getting to 1, right? So when we get 1, we point it to current, we check if no, if smallest value is none. Yes, it is none, right? Because our certain instance is none. So basically we point it to 1. So we point file index, as we see it, file index is just the file holding the smallest index that we found. So basically smallest file will be file index, so it's just going to be holding out that file for us. So yeah, so we are going to do that, and then we are going to go back to the top. Now we are going to have 1 here. Now we are going to check, oh, it's 1, its index is at 1, greater than 3? No, because our index is right at 1 is 0. Right, we now check for current file, right? So we check our current file. Our current will become what? To point to 1, right? Because files at 1 is this guy, and file at index as 1 is also 0. So basically we are looking at this guy over here, 3. And now this guy is going to compare his current, which is 1 at this point, less than 3. It's 3 less than 1, which is the smallest value at this point, so that does not match. So basically what's happening is that 3 is checking. We are coming here, we've already come here, we found 1, we are checking 3 against it. We are checking, we are going to come, the next one we are going to check again is going to the last on the for loop is going to give us 7, and we're going to check it against 1, and 1 is going to be the one to get popped in over here. So where does that logic come in? So we see if smallest value is none. So this guy over here checks for when we do not have a value at all within any of these lists. So basically the for loop has gone through the three lists, and it has not found anything. So basically none is not updated. So after coming up from the for loop, we still have the smallest value maintaining its initial state. So we break, right, and we call it a day. But if we don't, so we can then print out the smallest value, which is what we have here, printing out 1, right? And then we have indexes. So indexes at file, at smallest file, right, which is holding us the file. That's because obviously you know that we will notice that this indexes is like a representation of where we are at in our file, right? Like here now, because obviously at this last uh, line of code, line 94, is telling us that that we should increase this to, so never increase this to 1. You get, right? Because we've popped out the 1 here, so we are moving this guy now to 1, this 1 index. So basically what's happening is that we are using this to define where we are found to, or we have checked to in these individual files. So for this one now we popped out 0, so we're now pointing at the 1. For this one we have not printed out 3, so we are still pointing at 0 and 7 as well. You understand? So that's the whole idea. So we can now go forward to say, okay, what's the next guy on the beat? So we say we go to the top again, we make this now, we make this sorry, we make this none, and we make this file, right, 0 as well again. Now then we go from the top again, we now see file index in the range, so we know we are going to go 0, 1, 2, right, again. So we say file indexes, and this is not greater than 3, obviously, because our file index right now at the first instance is 1, right? Indexes are this thing. Is we have 1, 0, 0, so, and we know that these guys, all of them are 3, so we move past that. So our current over here is equal to files. File index equals to indexes file index, right? Basically, what are we doing? That guy is just basically saying, okay, so we have a current, and our current is going to be pointing toward the first file, which is, we say files at that index, which is 0, index of what, 0, right? Because we are looking at file index is 0, this is the first iteration. And then we see indexes, right, at file index. So basically when we check indexes at that file index, we have 1, so it's going to be, so current at this point is going to be something like, is going to be equals to files brackets 0, right, bracket 1. You get, so basically that's it. So when we check for this thing, we check to 0 and we check to 1, so we get 2. 2 is popped into our current. It's popped into our current. We check for the file, smallest value is none, so smallest becomes current, file index becomes 0, so 2 becomes the smallest value. So we go again. So when we go again this time around, we have our second iteration. So we are going to be looking at this list. So what do? We check if 3 is greater than 2. We check if 7 is less than 2 rather. So if we check all these guys and the two of them are not less than 2, so 2 get popped out. So that's the idea again. sorry, comma 2, right? So we can see that a pattern has been created. So now what's going to be the next bit? The next bit is now is that we are going to come in here and we are going to check 5, right? And we're going to get 5 because after moving, creating that guy, we're going to come here and increase it to 2 because we've moved past 1 and 2. So next guy we are going to come to is 0 and 5. So 0 and 2, so we get 5. So we now check, is 3 greater than 5? So it's 3 less than 5, my bad. So 3 is less than 5. So current now becomes 3 right here, right? In the second iteration, current becomes 3, and current, and then smallest value becomes 3. Smallest file becomes 2 because becomes 1 because file index is now pointing to 1. So we now also go again and check if 7 is less than 3. Do you get? So when we check if 7 is less than 3, 7 is obviously not less than 3. So we get to come out and pop 3. And when we pop 3, we also have to update this guy over here to 1 because of what we've moved on from the 0 index of the second file. So we go again and we check 0 again at the index of what? We check 0 again at the index of 5, and we check 5 again, right? You see, is 5 less than 6? Yes, 5 is less than 6. Is 5 less than 7? Yes, 5 is less than 7. So what do? We put that again. So we can see that. So we are checking every single iteration and we are getting the value. And if it's not the value, we check through all the list, and because we are sorted, right? We get 6 and we get 8, and we check the indexes, right? I mean the indices of the other files where we stopped. We've done with 3, we stopped at 1. So we are going to check 1 and 7. Do you get to now see, does it mix? Is this the lowest? If this remains the lowest, we pop it out. If this is not the lowest anymore, we change it. Right. So the key is also holding the file index, right? For all the files, holding that file index, so that as we also move, we know where our file stopped and we know how to continue basically on every file. So we can see here that the next one where we'll come here, we see that this first guy has been exhausted. So we come here, we see file index of this. Because now we've moved this, so we can see we can move this to 3, right? So when we come here, we see file index is am I correct? Yep, 1 2, yeah, 1 2 3. So yeah, so we check if this is 3 now, because this is 3 and it is equal to the length that we had here before. So what do? We continue. So we jump that guy over and we come to the second instance where index becomes 1. So we check index at 1, right? We check index at 1. So here, so basically we're checking this guy, and then we also check this one as well. So basically 6. So we say, is 6 less than 7, right? Because we'll come for the 7th one again. 6 less than 7, yes, 6 is less than 7. So that we're done with that guy. So the same thing will happen till we get 7, and then we get 9, and then we get 10. So basically that's the pattern that we hold. We keep just iterating until we get different values, and that's how we solve, and that's how this guy works. So but basically immediately we could then see the waste. The waste simply is the fact that every time we pick this guy out, we still need to go through this entire list again to check, wherever this guy stopped, do I have any guys at the forefront that that might be less than this guy that I've picked, right? So that's this for loop right here is the killer. This for loop right here is the waste. So this is what we see, and then we try to mitigate it immediately. So yeah, that's it for the graphical illustration. I hope you were able to grasp an understanding of what the concept is saying. Because next up we're going to look at the debugger tool. Then even more, we see exactly how the waste is in this for loop, right? We see how we move through the function in real time, and basically that will now cement our understanding of this solution. So see you on the next one. Muchas gracias. Bye.